All right, next we have group 7 with multigris.
Okay, hello everyone. So we're group 7, multigris. This is the team. Let's go. Okay, so what is multigris? This is a script that as an input takes observed line fluxes as well as prior parameter distributions, which you can predict or guess. And then you feed it into that, you select a model grid or a type of model. This could be cloudy or any of your favorite models. And you select a configuration, which is essentially a description of how you would estimate the region around your object. And then we use PyMC, which does all kinds of Bayesian magic to output predicted line fluxes as well as a posterior probability distribution of these parameters that would be useful. There's just a brief, just a little bit about the installation. It's all available on Git. It's quite easy to install. We found that it is good to use a virtual environment when installing dependencies for PyMC, so it doesn't clash with anything. And there's a very important pre-processing script that you have to run because some of the files are very big and they're in binary. So in order to be usable, they need to be converted first. Okay, so the most important part that you have to, what you have to give it is an input file, and this is some of the basic structure of it. The most important part is, okay, so the context, which is the model that you decide to use, as well as your configuration. Here is an example of one of the most basic configurations, and visually you can think of it like this. This is a singular cluster, you know, or nucleus or whatever, and then a thick shell, or that you can make the shell consist out of various different properties. This is like a three-component shell. Then you give it any of the lines that you may have. So you give it the line fluxes as well as their errors, and you run these three commands in order. This one does all the basic processing. This one converts what this one does into a more readable format. And the post-processing, I think I'll skip for now. So we applied this code to 3 different objects. E and I did the first one, and she will tell you now more about the first one. Thank you.
We use this package firstly to fit with a high redshift galaxy at redshift 10.6, which used to be the most distant galaxy we have ever detected. And here I show the image and the spectrum of this galaxy, and the table is the physical parameters this paper used Beagle ICD feeding to derive. And now we firstly use the bound cloudy model grid to try to derive the physical properties of this galaxy. But as we can see that the age is not good compared to the paper. So and now we also try to fit with 2 components, but the age is also not good. Then here I show the plots where we can see the comparison of the prediction and observation of the emission lines we used to fit. And we can see that the magnesium 2, the nitrogen 3 and nitrogen 4 lines are not consistent with the observation. So to try to mitigate this tension between the prediction and observation, we consider to increase the AGN fraction in this galaxy. So to fit with AGN fraction, we use LLC model grade. And here we can see that when we fit with AGN fraction is 0%, the parameters are very well consistent with the values in the paper. But when we increase the aging fraction to 16%. The metallicity is not consistent with the value in the paper. So we think that the aging fraction in this galaxy may be close to 0%. And here I also show the same plot. We have everything before. But even when we fit with aging fraction, the tension between the prediction and observation of the line of these three lines is still exists. And then we also try to fit with two components, but however, this tension still exists. Okay, this is next project.
Hi, for my project, I was curious to compare what the multi-GISM output would be, the posterior of predicted the metallicity would be given the manga galaxy. So what I did was I selected a galaxy from Mingori 2020, and these are all the available lines in this galaxy. There are 35 total, but there are 27 lines that are modeled by the cloudy grid. So what I did was I started with the IFU and then reduced down to the integrated lines for individual fluxes, and then compare that with the manga prediction. Oh, it doesn't work. So this is a simple pipeline. So as an input, as I say, 27 individual lines, and then I put it onto the multi-GISM, and which predicts produce a posterior distribution of metallicity given observation and model of cloudy. There are many models available, and I just highlighted 4 different models, which are like characterized by number of shells and number of a cell cluster. And we found that the second complex model, which has 1 cell cluster and 2 components, are most preferred given marginal likelihood and cross-validation score. We also corrected for the dust extinction, and we also did the helium to hydrogen correction and apply some appropriate prior. So these are the predicted metallicity from our posterior, which was really low comparison to what is predicted by the manga collaboration. And there are 2 reasons that we can come up with. Perhaps we are fitting like 27 lines to simple models. It only has 2 components, so maybe it is too simple. The other one is that the data might be not consistent. The ratio of like O3, O2 ratio of our emission lines, which are strongest oxygen emission lines, doesn't really agree with what is published in their paper. And we see that there are about like an order of magnitude smaller than what is predicted. So maybe that is why we have underpredicted the metallicity.
Okay, so I've done a third application of this project where I tried to look into a galaxy, an object that is taken from SAMI Galaxy Survey, and this object, I just found it in this paper. So here is some description about what the object is and what is its RN deck. So I have got an IFU flux map for H alpha and a few more lines. So what I did was to compute the integrated line fluxes and line errors using Python. And it's like a very faint source. And then these line fluxes and errors are treated as a parameter to the model. So the next step was to pass these parameters into the multi-GISM, and I have chosen 3 different kind of configuration. The first one was 1C1S, where I have taken 1 component and it has predicted the metallicity value of -0.28. And then the second metallicity grade, second configuration, which is like 1 single galaxy and 2 components, and that has predicted a metallicity value of 2.83. Whereas if I would have described it better, like in description, so there's a huge error bar for 1C2S rather than 1C1S, which is why we went to see the third configuration to see if we have having configure a whole distribution of metallicity, and then I predicted the model predicted the value of metallicity somewhere nearby 0.39, which is when compared and look into the paper, which is there's a huge discrepancy we are finding looking into this. There are several reasons for this. The first one is in the paper, they are looking into specific calibrations on different, and for they're doing different calibrations and using different kind of correlation fitting and everything. And they're using radiation bounded models where this model is using matter bounded. If you'll see the oxygen 16300 line, it is showing a very huge deviation from the observation, like difference between the observation and the model. And the third one is if the two component model fit the object very well. So we tried to do it like I was thinking to do it to 3 model or 2 component models, but probably we'll do it later on. So that's all from us. Thank you very much.
Thank you. So, do we have any questions?
So did you have a chance to study the posterior distribution of some of your parameters to try to see if there were some degeneracies between, you know, the different components that you use?
I think
Sorry, what are you trying to say? Like discrepancy between the parameter posterior distribution and which one?
No, I mean, so, you know, you have several components, so it means some parameters usually are degenerate in this kind of fits. So do you have a chance to study that from the PDF?
Yes. For my case, I studied it, and there is no discrepancy, like from the MGRIS modeling, there's no discrepancy in predicting metallicity and age, but there is a different weight that is weighted onto different components. So that kind of affects the overall fluxes, predicted fluxes. But for parameters, there's not really a big discrepancy.
All right. Any other questions while group 4 come down? Well, then let's thank group 7 again. Thank you.